So I think it's time to start. Yes. Good afternoon, everyone, and I'm very happy that you are here today. First of all, I would like to introduce myself and our team. My name is Edyta Puniach, and I represent AGH University of Science and Technology, and Kamila Nocoń from Jagiellonia University is with me today. We are going to talk about the 3D documentation of ceramic vessels, and we'd like to present you the results of our studies, which was made by our team, which consists of one archaeologist, one metrology, and 3 surveyors. As you can know, documentation in archaeology is a very important task. And nowadays, photogrammetric methods are very common and used for this purpose. To make the photogrammetry documentation of archaeological objects more simple and more accurate and even faster, the device called FocusSphere was designed and constructed by one of the co-authors of this presentation. FocusSphere is a close-range photogrammetric measurement machine consisting of turntable. No, I don't know how to work it. Okay, so it's a turntable and the boom with the mobile trolley on which the camera is mounted. It's a very low-cost solution to make the measurements. FocusSphere allows us for automatic acquisition of photogrammetric data, and its characteristic features is that we know coordinates of control points placed on the turntable, and we know elements of external orientation of images. It has to be noted that FocusSphere is only prototype and it's still under development. To document the object, first of all, this object must be placed on the turntable, and then the photos of this object are taken from all its sides. For this purpose, FocusSphere make alternate movements between the trolley and the turntable. First, at the beginning, the photos are taken from different position of the camera mounted on the boom, as you can see here. And then the turntable moves to another position, and the process of taking photos from different position of the camera starts again. In this way, photogrammetric data are collected and can be processed in photogrammetric software such as Soft Photoscan. Because we know the coordinates of control points which are on the turntable, and we know the elements of external orientation of images, the process is quite fast and it's more accurate than in traditional way. As a result, we can obtain some photogrammetric products such as dense point cloud, mesh models with high resolution texture. Now, when you know what is FocusSphere, I'd like to present you our aims of study. During this presentation, we focus on verification of the accuracy of 3D models, which are created with the FocusSphere. However, now I would like to say a few words about the verification of the accuracy and repeatability of camera positioning in FocusSphere. These 2 parameters can inform us about the accuracy and repeatability of elements of external orientation of photos, which are taken with the use of FocusSphere. and these two parameters are determined in accordance to the standard for testing robots. These measurements were divided into parts and were done with the use of a laser tracker. And the measurement accuracy is 0.1 millimeter. In both cases, 30 series of measurements were carried out. In the case of camera positioning, there were made measurements in 4 points where a trolley stops on the boom. And on this basis, we estimated that the camera positioning repeatability is better than 0.1 millimeter. Similar measurements were made for the turntable. In this case, 20 different positions of turntable was measured also in 30 series. The parameter of repeatability is a little worse and is about 0.5 millimeters. But as a conclusion, I can say that the repeatability of the device is better than 1 millimeter, and it was the value estimated by the constructor of this device. But I think it's time to move to our main goal. So I'd like to talk about verification of the accuracy of 3D models which were created on the basis of photos taken with FocusSphere. The first step of these studies concerned selection of the vessels which were documented. I think that this process will be the best described by our archaeologists from our team. So, Kamila, floor is yours.
Thank you very much, Edyta. So I would like draw your attention for our selection of our vessels. All the vessels which are visible in here are from the Jagiellonian University Institute of Archaeology and from our collection of antiquities. And we decided to choose 17 first vessels were selected, but we decided to choose vessels which can be divided to the different groups. First of all, the chronology, the very, very old one from the Bronze Age to the Archaic period from Cypriot, and the second group was the decorated vessels from the Corinthian and Athenian and Campanian workshops. And what was really important for us, it was the size and the sparsity of the object. And you can see that most of the vessels which were chosen are quite rounded. The second most important thing was the stable setting of the vessel on the table. We choose objects with open and closed form, as well as flat frames and handles which are not so big. Another very important thing was external surface, which should be rather matte or glossy, because we would like to see how it's going to be with the glossiness of the vessels, especially that one from the black figured and red figured technique. So as I said, we decided to document 17, but at the final stage 8 of them were documented. So this is a very simple slide, and I would like you to say something about the basics of the documentation. Archaeological documentation of the pottery. So as we all archaeologists, we do exactly know how to do it, but the most important thing is to show the vertical cross section of the vessel. But now, thanks to our team, we are able to show much more, and Edyta will tell you about our next steps of our project, I think.
So the next the next obvious step of our study was to create photogrammetric documentation of selected vessels. Of course, we used for it FocusSphere. Now I'd like to draw your attention only to the problems which occur during this process. We have some problems with glossy objects. As you can see, the creating dense cloud and aligning photos was problematic for such vessels. Fortunately, we found a solution which wasn't very complicated. Correct light control and using dulling spray turned out to be very helpful and help us to obtain correct photogrammetric products for these vessels. We also like to verify the accuracy of obtained models, and we perform reference measurements with measuring arm. Using this device, we do measurement with accuracy of 0.3 meters, and it's worth to say that the type of measurements is touch trigger measurements, and the position of the probe, which is situated at the end of the arm, is determined during the measurements. Our reference measurements were based on the points which were placed on the surface of the vessels, especially on characteristic sections. The measuring procedure, especially preparation for measurements, was rather time-consuming. In this step, selection of characteristic points being control network and definition and indication of characteristic section was most important. After that, data acquisition was rather fast, but there also occurred some problems, and it was connected with no possibility to measure complex shapes and no possibility to measure accurately points where two arches meet. As you can see here, it's because of the radius of the probe. The processing of reference data takes several steps. The first one concerns the projection of measure points onto section planes, and it was rather simple. The second one was the most important, but also the most problematic step during the development of data, because we must reduce our measurements because of the radius of the measuring probe. You should know that during the measurements, the center of the probe, the coordinate of the center of the probe is determined, and we are interested in the coordinates of the points which are placed on the surface of the vessels. So we have to take this offset into account. And the last step of data development was quite simple, and it was connected with drawing the spline lines. As a result, we get the final section lines of our vessels. In this way, we documented 7 vessels, and we estimated that the accuracy of section lines is about 0.3 millimeters. Section lines was then compared with photogrammetric models and the drawing documentation for each object and for each section which we measure. And let me show you the results only for one vessels because of the time. These slides show the vertical section of one of the vessels and some characteristic places of this section. As you can see, the difference, the distance between the section line and the photogrammetric model is about 0.5 millimeters. On second, the next slide shows one of the horizontal section, and here you can see the obvious advantage of photogrammetric documentation. As you can see, the photogrammetric model is very detailed, and using the measuring arm did not allow us to reconstruct the shape of the vessel as detailed as the photogrammetric tool. However, this slide sums up the results of all our analysis, and the parameters which are here are related to all measured object and all measured section. As you can see, the accuracy of 3D models, 3D photogrammetric models is 0.4 millimeters. What's more, there is no systematic error between these two data sets, because the mean value of the distance between section lines and the photogrammetric models is only 0.1 millimeters, and it's the value less than the accuracy of reference measurements. In the end, I'd like to show you only the comparison between the section lines and the drawing documentation of the same vessels. As you can see, the differences are much bigger and exceeded even 4 millimeters in some places. And as a conclusion, I'd like to underline that FocusSphere can be used for documentation of archaeological objects and meet the strict condition of geometry and texture accuracy. This method is safe for objects, and it can be fast and reliable solution for digitalization of selected objects or even the entire collections. And it's everything we'd like to show you today. Thank you for your presence, and we are encouraged you to ask questions.